Hi, this is the last of the three parts. In this last part, we will go through a quite different methods. But the common thing is that we can explore the underlying structure among a large size of data. And we can visualize the data based on the discovered structure. So in this part, we will explore an underlying structure and visualize the data. We like to look at the data distributed in a two-dimensional space because we can intuitively catch the internal relationship between the plotted items. These items can be independent variables or dependent variables, or sometimes the people who have evaluated the dependent variables. Also, we can define the plotted items in terms of the characteristics of each axis. In this part, we learn how to extract an underlying structure, so underlying axis, latent variables, cluster similar variables or cases, display the data, or visualize the network of the data. So the methods are grouped into four. They are vector analysis, cluster analysis, multidimensional scaling, and network analysis. Approach-wise, each has quite different logic behind. Among these four, the most statistical one is vector analysis. The other three are quite tolerant in terms of statistical significance. However, they are very practical, especially for design research, because we can simplify the data structure and visualize it onto two-dimensional space. Here you are presented with a lot of everything. A lot of stimuli, a lot of subjects or subject groups, and a lot of measurements. Considering this example, I will explain you for which purpose those techniques are useful. First, the vector analysis. The vector analysis clusters variables and extract the underlying factors. One factor is equivalent to one dimension. So in a research, when factor is mentioned, it is often automatically associated with dimension, a concept of dimension. And consequently, the factor implies an independent relationship between factors. Therefore, you should be very careful not to misuse factor in your research paper. And the factor is called 요인 in Korean. Initially, we had 20 adjectives as dependent variables. We will try to evaluate the characteristics of the many colors in terms of these 20 adjectives. Each of the 20 adjectives can be facilitated to assess a certain characteristics of a single color. But suppose when a color has a high score in terms of cute, then it is not difficult to guess that that color would have obtained a quite high score as well in terms of lovely. Asking how cute a color is actually quite similar with the question how lovely a color is. In such a way, the scores of colors may be correlated between certain adjectives. Based on the correlations, some dependent variables, in this case some adjectives, can be clustered. This is how the vector analysis is working. In measuring the characteristics of different colors, we extracted these four factors. And then we have labeled the factors as flamboyant dimension, elegant dimension, clear dimension, and soft dimension, respectively. However, even though you use exactly the same adjectives, if you assess different substance, you will observe a different clustering. Cluster analysis is 군집 분석 in Korean. In cluster analysis, the Euclidean distance between observations is the base to make a group. But in factor analysis, the correlation coefficients do the job. Cluster analysis is used in order to group similar observations with respect to a set of characteristics. A set of characteristics can indicate the tendency of assessments. For example, Koreans and Italians show similar tendency when they make a judgment of characteristics of a color. Then these two countries will be clustered. When the number of observations, in this case a number of countries, is not that big, then a dendrogram, this tree structure, this dendrogram is quite practical to overview or to observe how each item or how each cluster is clustered or joined to another cluster. Or you can cluster stimuli too. If you use the SPSS, you need to transpose the data matrix, but technically it is also possible. Technically, you can cluster even variables too, but then the variables are clustered based on the Euclidean distance, not based on the correlations coefficients like the factor analysis does. And differently from the factor analysis, in whatever situation, a cluster analysis will always give you a result. Therefore, cluster analysis has nothing to do with statistical significance. Then it is about the MDS, multidimensional scaling. MDS visualizes the independent variables or dependent variables, or overlaps both independent variables and dependent variables. Based on the visualized results, you can understand the relationship of the conceptual distances. For a practical reason, you prefer two-dimensional presentation. In 1980, a physicist, Kobayashi, proposed a color image scale. He tried to deploy color chips into a three-dimensional space, which is profiled in terms of warm, cool, soft, hard, and dynamic, static. Again, for a practical reason, the first two dimensions are mostly mentioned. After positioned colors and style words in another coordinate, he overlapped these two coordinates to indicate which color corresponds to which style. And this color image scale is still very much widely used. And lastly, we will practice the network analysis. I think you remember that you participated in this in the first week of this semester. You made a link between two objects and you defined the direction. A network analysis requires nodes and linkage between. The linkage is also called as edge. The linkage can have a direction, but it is not necessary to create a network. Based on the number of linkage, the thickness will be decided. The more often a certain nodes are mentioned, the node size will increase. For example, among your answers, wearable device or mobile device were the most frequently mentioned. Consequently, these items are bigger than the others. And these are positioned in center, networked by different items. Meanwhile, there are tens of different tools developed for network analysis. Among them, a shareware software, Gephi, will be used in this semester.